A solvent's colligative property is one that changes and depends on the quantity of particles of solute dissolved in the solvent. It does not depend on the identity of the solute. Two examples of a colligative property are boiling point elevation and freezing point depression. The reason freezing point depression occurs is because more time is required to overcome the barrier to crystallization due to the solute's particles' interference with the IMFs between water molecules needed to crystallize. You can see here the sodium and the chloride ions are getting in the way of the IMFs between the water molecules. So in solving this equation, I just write down the knowns and the equation that I'm going to use. So molality is moles of solute per kilograms of solvent. So in this case our solute is sodium chloride. So to find the moles of sodium chloride, I'm just going to set up the conversion, and I'm going to divide the grams of sodium chloride by the molar mass of sodium chloride to get moles of sodium chloride. And there I accidentally wrote grams, but it's moles of sodium chloride. So now this is just sort of showing the work behind the kilograms of solvent for water. So I have rho H2O is 1 gram per milliliter. So I just convert liters of water to milliliters of water, and then I convert that to grams of water by doing the multiplication in my head of 3,120 times 1, and then I finally convert it to kilograms by dividing by 1,000, so it's back to 3.12 kilograms of water. So now finding I, so sodium chloride breaks into sodium ions and chloride ions. So I equals 2 for 2 particles. So finally plugging back in everything into the equation. First we need to find molality. We found each aspect, the moles and the kilograms. Now we need to actually plug it in to get the value. So the 0.512, that's constant, and then I multiply by 2 for I, and then 0.3247 for molality. And then I get the change in temperature to be 0.3325 degrees Celsius. So now the new boiling point is what pure water would be, which is 100 degrees Celsius plus the change in temperature to get 100.3325 degrees Celsius.